Well, recall in the previous video we did this problem where we had some grouped data and 8 people got between 0 and 5. So we said the midpoint of 0 and 5 is 2.5. And the midpoint of the next range, 6 to 10, was 8. The midpoint of 11 to 15 was a 13. The midpoint of 16 to 20 was an 18. So we consider these midpoints to be the score that each of the students got. So we're going to call these midpoints. This would be like midpoint 1, midpoint 2, midpoint 3, midpoint 4. Okay, well, let's generalize that formula in number 8 here. If the data are grouped into intervals where M1 through MK, these are the midpoints already computed, and F1 through Fk are the frequencies for each category, respectively, then an estimate of the mean of the data is as follows. Now remember, this is the midpoint of the first range of data, and F1 is the frequency, the count, the number of numbers that are in this range. M2 is the next midpoint, and F2 would be the same, the number corresponding to that, and so on. Finally, the very last midpoint is MK, and F sub k would be the count or frequency of numbers in that range. So the mean is going to be very similar to something we've seen before. It's going to be mean 1 times frequency 1 plus mean, I should have said midpoint 1 times frequency 1, midpoint 2 times frequency 2, and go all the way to the last one, which would be m midpoint k times frequency sub k. And then we'll go ahead and put that all over n, but we have to define what n is. N, once again, is the count of all of the scores, or all of the numbers. So we have to add up all of the frequencies. F1 plus F2 plus ... all the way up to F sub k. Add up all k of those numbers to get the total number of numbers that we're averaging. So that's going to be our denominator n. In other words, n is the sum of all of the frequencies. Okay, number 9. On the final exam in finite math, 10 scores were in the 80s and 12 scores were in the 70s. Let's estimate the mean score. Well, we don't have a table here. So what does it mean? What would we use as an average midpoint value for the 80s? You might say 85. Well, is that right? The 80s go from 80 to 89. Right? That's kind of our range of values. And then 70s, maybe I'll put the 70s above it, 70 to 79. Let's compute our midpoint. I'll call it MI. So basically we're going to have M1 and M2, two different midpoints. So the midpoint of this one would be, I need to give myself some more room. What we want is, I'm going to put it in the same order, 80 to 89, that's the 80s, 70 to 79, that's the 70s. So the midpoint is going to be 80, 1/2 of 80 plus 89. This is going to be 1/2 of 70 plus 79. If you want, you can just count inwards until you get to the very midpoint. But I know what it's going to be. Remember that from 0 to 9, the midpoint is 4.5. So from 80 to 89, it's going to be 84.5, 84.5. Adding these two and dividing by 2 is going to give me the middle point. It's going to be 74.5. So that's my midpoint. I'm going to use only these two different values to compute my average. And then I need the frequency, F sub I. How many scores were in the 80s? 10. How many scores were in the 70s? 12. Now I have a frequency table, and all I really care about is this right here, and the total number, my n, which I'm going to divide by, is going to be 22 because there were 22 students in this class. 10 scored in the 80s, 12 scored in the 70s. So for the mean, I'm going way over here to the left. I multiply these two things together. 84.5 times 10 plus, multiply these two things together. 74.5 times 12 all over 22. And I don't have that worked out, so I'm going to pull out my calculator and get 84.5 times 10, that would have been easy, plus 74.5 times 12. And then I divide that by 22, and I get 79. I'm going to round it off to 79.05. Just like that. So very, very close to just a plain 79, which does make pretty good sense. We had just a couple more 74.5s than we did 84.5s, and so that seems like a reasonable score. That is our mean mu for the 22 students, where 10 scored in the 80s, 12 scored in the 70s. All right, that's the end of our mean and group of mean of grouped data. We're going to look now at the last method, or central tendency, a measure of central tendency. Actually, we're looking at the second of the measures of central tendency, and it's going to be the median. M-E-D-I-A-N. It happens just to be the middle number after your data have been sorted into increasing or decreasing order. So if the number of items in is odd, then the middle number is the median. If n is even, then there is not a middle number. There would be two right in the middle, and you take the average or the mean of those two middle numbers. So just need to remember those two special cases. All right, so for our first example, let's see. Fortunately, all these numbers are in increasing order. So I got to find the middle one. So it's not that, that, that. So it's going to be the number 10. And notice you've got three numbers less than, three numbers greater than. So that's what it means by the middle number. So the median is 10. Okay, so this is fairly painful on this one because why? They're not in order. So I'm going to write them in increasing order. You could do either increasing or decreasing. I'm going to start with 1, 2, 3, 7. I think if I saw those correctly, there's a 1, 2, 3, and 7, and then 8. That's all of my one-digit numbers. Then 13, 17, 19, and 31. All right, let's find the middle number. So I'm going to go from the left and right. I'm going to get there, then the 19 and a 2, the 17 and 3, and then 13 and 7. So that is our median, the middle number. And just to verify, notice we have 4 numbers less than 8. We have 4 numbers greater than 8. All right, so on number 13, these appear to be in increasing order. That's good. Let's go find the middle one. Let's see, 22 and 7, 21 and 7, 19 and 9, 19 and 10. 14 looks like it's the middle number. Let's verify that. I've got 1, 2, 3, 4, 5 numbers less. 1, 2, 3, 4, 5, 5 numbers greater than. That's the middle number is 14, the median. And the last example for this video, I've got to sort them again. So 1, 2, 9, 10, and then 14 and 17. All right, and finally, we do not have an odd number of numbers. We have an even number, 6. So notice what we have to do. 17, 1, 14, 2. I'm going to circle both of these because the median is going to be the midpoint of these two numbers, or the average of these two numbers. 9 plus 10 over 2, which we know what the midpoint of 9 and 10 is. It's 9.5. 9.5, or 9.5. Okay, so interesting when you talk about the median. We just showed an example where the median of a set of numbers does not have to be one of the numbers. If you have an odd number of numbers, it's always going to be that one single middle value. But when you have an even number of numbers, you have to take the average of the two middle numbers. So it's likely not going to be one of these numbers. Now it would be, it's possible, if you had a 10 and a 10 as the two middle numbers, then the median would be 10. But in this case, the median was 9.5 or 9.5.